The question says that a closely wound solenoid of 2000 turns, an area of cross section 1.6 into 10 to the power minus 4 meters square, carrying a current of 4 ampere, is suspended through its center, allowing it to turn in a horizontal plane. Now we have to find out what is the magnetic moment associated with the solenoid and what is the force and torque on the solenoid if the uniform horizontal magnetic field of 7.5 into 10 to the power minus 2 Tesla is set up at an angle of 30 degree with the axis of solenoid. So there is a solenoid and that is hanging. So we can assume from the top view that the solenoid is this is the solenoid, and a uniform magnetic field of magnitude this much, that is 7.5 into 10 to the power minus 2 Tesla, is set up at an angle of 30 degree. The angle between this solenoid axis and the magnetic field is 30 degree, and we have to find out what is the magnetic moment associated with the solenoid. So magnetic moment will not be influenced by the magnetic field. So magnetic moment is defined as M equals to NIA, where N is the number of turn of the solenoid and I is the current flowing through it, and A is the area of cross section of the solenoid. We have been given the data, all three data, so we can find out the magnetic moment. And the second question says that what is the force and torque on the solenoid when this magnetic field is set up. So torque on the magnetic dipole is given by mv sine theta, that is m is the magnitude of magnetic moment and v is the magnitude of magnetic field, and theta is the angle between the magnetic moment and the magnetic field, and here it is theta equals to 30 degree. We also need to tell what is the force on the solenoid. So we know that since the magnetic field is uniform, no net force would be acting on this solenoid by the uniform magnetic field. So force is going to be 0. Now let us calculate the magnetic moment and torque on the solenoid. So magnetic moment would be equal to NIA, where N equals to 2000 and I is 4 ampere and area of cross section is 1.6 into 10 to the power minus 4 meter square. So we will get a value of 1.28 ampere meter square. And the second question said that what is the torque on the solenoid. Since we know that the magnetic field is uniform, so force is going to be 0. So calculating torque, we can use the formula mv sine theta, where m is 1.28 and the magnetic field is 7.5 into 10 to the power minus 2, that is given. So we will get a value of 4.8 into 10 to the power minus 2 Newton meter torque. Thank you.